expertise spans several emerging and impactful areas, including thermoelectric generation, photovoltaics, VLSI, renewable and rural energy systems, advanced cook stoves, and speech recognition technologies. Through her dedication to innovation and sustainable technology development, Dr. Rishamal Ma'am has made valuable contributions to academia and interdisciplinary research. Her work continues to inspire young researchers and students in the field of sustainable engineering and energy solutions. It is my privilege to welcome Dr. Rishamal Ma'am to this conference. Thank you, ma'am.
Thank you for this flattering introduction. Good morning to all of you. Am I audible?
Yes, ma'am.
Yes, okay. So quickly I'll share my presentation and then we will start. Okay. So as far the introduction goes, it has correctly said that I work in renewable energies, and today I will be talking on the topic of innovations for off-grid standalone energy systems for net zero emission environment. So good morning to all of you, myself Dr. Risha Mal, and I am working now at Indian Institute of Technology, Guwahati. So this is how IIT Guwahati looks like. I thought of giving a short glimpse about my institute where I work into. So it's one of the premier institutes, stands on 7th position among all the IITs and holds its rank of 351 in US global ranking. So this is how the campus is, very beautiful, surrounded by lots of lakes. And if anyone get a chance to visit here, you are most welcome. This is about me, what I do. So I have developed a lab at IITG named Sustainable Energy Laboratory, and this focuses mainly on renewable energy systems, solar PV systems, thermoelectric generation, which is my expertise, biomass energy, and rural energy technology. Again, since you are a community that comes from electrical engineering, me be a student of electrical and electronics engineering, how I have diverted and routed my expertise into rural energy, since now I am working in a school known as School of Agro and Rural Technology. I'll give the whole touch to this roadmap, how I have ended up here. So I have developed few things for rural communities like solar PV powered cane slicing machine, PEG integrated stove, and many sustainable energy technologies for rural communities. Okay, yes. So I am an electrical engineer, but I work on the electrical engineering domain, but for the benefit of the rural masses. The research division for my lab is the practically developed technologies, standalone off-grid technologies that is accessible to everyone, so that the rural livelihood can be developed and it can lead to sustainable development of the country as well. My current researches are, we have a solar PV thermoelectric powered e-list drying system, and we have many such solar PV powered agricultural processing machines, and we have also developed many technologies that are affordable clean energy solutions for rural areas. Now, as far as the title of my today's talk goes, I have told about three nomenclatures which are prevalent in the topic. So I'll first discuss the nomenclatures of what are the meaning of those words, and then maybe I'll move forward. So first thing is off-grid. What do we mean by off-grid? We know grid, since we are from the background of electrical. But off-grid is something that we are not actually using the power that is being given from the, so that is not taken power from the grid, and it is totally sustainable of its own. It is self-sustained and do not rely on any power that we are getting from grid. Next is standalone. Standalone is a device which we can operate in from a remote area, and it may require power, but standalone do not standalone means it is an off-grid system, and it can be operated from a remote power. Next is net zero emissions. What do we mean by net zero emissions? This is a term that has been evolved when we were having the climate change Paris Commission, when they were establishing the SDGs. They said that we should have a net zero emission. That means the balancing amount of greenhouse gases that has been released in the atmosphere. So how do we do that? We know that trees do take carbon dioxide to, sustain their growth. But this carbon dioxide, where do we get from? We get it from in the process where we exhale, in the process where we have emissions. So these both the carbon dioxide that we emit in the atmosphere should be balanced. So this balancing should be as such that there should be how much is given to the atmosphere should be taken by the plant. So that's how it works for net zero emission. Right. Now, these are the sources of standalone energy systems. So we have so many energy systems that gives power to our household and day-to-day life. So we have a very conventional thing that we have in a thermal power plant, that is coal. We use coal for generating energy. For renewables, we have wind energy, we have uranium, petroleum again is a fossil fuel, hydropower is a renewable energy, solar energy, geothermal, hydrogen is booming now, and natural gas and biomass. So these are the things which actually contributes for the sources of standalone energy, sources of energy. Now, the Paris Climate Agreement, what were the key points for the global, so that we have this global impact of giving a shot to the climate change? So they had certain things that they have pinpointed and said that these are the things that has to be looked over, and this is how we contribute to the nation. So the first thing is temperature. We knew that the temperature is rising every year substantially, and the ozone is being affected. So they said that we should keep global warming in check, and it should be well below 2 degrees Celsius per year. So this thing was the primary key point that they have to check. Next thing was finance. Now we have number of countries which are actually third world developing countries. So those countries need help. They have established that those countries will be given help financially so that they can support innovations, and so that they can so that they contribute efficiently in keeping the check of climate change. Then yes, they have made efforts with technology by making researches and taking the lead by the developed countries. So the developed countries have taken a lead to make or mitigate the climate change. Then they also said that we have emissions which we know should be mitigated, and these emissions should be kept down well into range. So the use of renewable energy is promoted very highly. This is more or less same as the finance burden sharing. Burden sharing is where the developed countries come forward and help the other developing countries with resources and finance. The review mechanism, they will all meet together in some point of time, and then they will review whether the goals that we have set forward has been taken care of, and it is the temperature and all the things are kept while in check. And the climate damage. So they are also saying that whether the countries that are very vulnerable should minimize the losses that are being suffered due to climate change, and they should check on what the things affecting the climate change, and that has to be mitigated. So this is for the vulnerable and the developing countries, that they have told that they have to make this prominent, that they have sufficient amount of efforts to make the climate change happen. Now this is where we see this graph or say picture, where we can see that the most important thing of climate change and how it can be benefited is actually related to affordable and clean energy. So affordable and clean energy actually is benefited for all the 17 SDGs that we have. So if we have affordable and clean energy, that will support every SDGs of the climate change SDGs. So the affordable and clean energy is the primary thing that we have to take care of. So which will help in sustainable growth, human development, and also environmental sustainability. Now, when we are talking of climate change, there are certain components which enables the environment for off-grid renewable energy solutions. So what are these components that has to be taken care of so that this climate change can be taken care of? So we should have policies and regulations. We should build capacity so that more and more people are aware of it and they can actually contribute to the climate change. And then we should also have some institutional frameworks where the institutes come forward with their researches and can contribute for the climate. We should have some delivery and financing models because government nowadays finance so many projects for clean energy development systems. And also we should have cross-sector linkage because it's not desirable to stay in one particular institute or one particular state and then think of contributing for the climate change, but we should come forward and hold hands to together make the things work so that interdependence of or interworking of both the sectors or many sectors together should come forward for working together. Next is technology. We should come up with new and novel technologies which can promote and mitigate the climate change effects. So yes, we are all trying our best in our own way to make this thing happen with the help of technologies. Now, we will look into some of the renewable sources of energy and what is the percentage of those renewable sources of energy which contributes for the nation's development. So we have wind power, which contributes to the 10% of the total renewable energy sources. We have geothermal, which is again 10%, tidal energy power, which is 10%, biofuel 10%, hydroelectric power 10%, solar power 10%. So we have this whole bunch of renewable energy sources which can contribute for the development of sustainable energy system. But one of the major renewable energy sources which we have overlooked over the time is biomass energy, which is also 10% of the total renewable energy sources, which is overlooked has and not been explored greatly for energy or power delivery for as the case of renewable systems. So yes, biomass has potential of giving clean energy, but how it has to be done is a challenge, and it is been looked over time. And we are trying to develop technologies which actually run on biomass energy. So before starting with biomass, for the first technology, I will be concentrating on the biomass technology which we have developed in our laboratory and which runs efficiently. We have developed a system that runs efficiently on biomass, and it is capable of giving power from the biomass energy. So first of all, we will introduce the biomass, what it is. Biomass is nothing but it is all sort of organic matters like plants, waste like wet waste, and any organic matter you can talk about which comprises of biomass. So biomass refers to an energy source, and it can be successfully harnessed. The energy can be successfully harnessed by directly heating, by combustion, by burning the biomass and produce heat. One such application is cook stoves. So nowadays, cook stoves, earlier it was like cook stoves were used in most of the households, but nowadays cook stoves is predominantly on the rural sector. So people who reside in the rural areas still use cook stove for cooking. I'll pause here for a minute. I have a question for the audience. So may I look upon the people with their raised hands who knows what a cook stove is? What a cook stove is? Cook stove, or in Hindi you can say chulha. In rural areas, people use those for cooking purposes. Are you aware of it? Can you raise your hand and let me know who are the people who are aware of cook stoves? Yes, I can see a professor raising hands. Two professors, yes. Anyone else? No. I just need a interactive thing because I will be talking about cook stove for a little bit of session. So I need to know whether you people are aware of what do you mean by cook stoves. चूल्हा जानते हैं? हाँ? सबको, the one in back, nobody? Please, a hearty response is very welcome. Yes? Okay. I can understand that professors do know what it is, but I think students and scholars, they are little bit skeptical about what do you mean by cook stoves. Is it so? Okay. Right. So, I'll come back again to my slides. So one such application, as I said, is a cook stoves. And 32% of urban area and 68% of rural area predominantly rely on cook stoves. So it is a very huge number. But then, yes, they are used till date. What do we use for cooking in our household? We do use LPG gas, right? Right? Yes.
Yes,
So
ma'am.
we do use LPG in our household, but then there are so many households in the rural areas who use cook stove. So here we can see by the statistics of the rural area of India and the urban area of India, it is a little bit of older statistics, but after that nobody has taken for the statistics after that. So it says, it gives a faint idea of what it is like, the scenario of cooking in the rural and the urban. So in the rural area, you see a larger chunk of people are actually relying on firewood, crop residue, cow dung cake. A very small percentage of people are actually relying on LPG. But on the other hand, on the urban side, most of the people are using LPG, but substantial amount of people are using LPG, but a very shrink percentage of people are using cook stoves, firewood, crop residues. The one that who stays in the slums or in a very poor condition, they actually use those cook stoves in the urban. So we can see a clear difference of usage of cook stoves in rural and urban areas. Now, what is the impact of using those cook stoves? The impact is we have environmental hazards. The environmental hazards, where WHO has reported that nearly 3 billion people cook food in open fires and burning biomass. And the statistics say that 4.3 million people actually die prematurely from this illness due to indoor air pollution, and the population mostly are women and children. Now, this is what a cook stove looks like. Now, who do not have, the person who have not seen may recall, or I do not know whether I am good with the language that what you use to call this stove. Is there any term for this stove?
Ma'am, in Andhra we call it as katla-poyi. So, yeah.
Okay.
It's the same thing we use.
That's
Yeah.
good to.
Yeah.
Okay. So I think because of the language, because of the term that I'm using, most of you have not understood what it is. So this is what the stove looks like. This is predominantly used in rural areas. So yes. So what is this? They use this for cooking food, and yes, and many countries, all over the globe, many countries use this cook stove or three stone fires we call, three stone stove we call, they use it for cooking. So these are some of the places like Cambodia, we have Nepal also, we have Guatemala, where this kind of stoves are actually used till date for cooking. So these are again used on biomass, and they use agricultural waste, cow dung, cakes, those sort of things to feed inside the cook stove and then burn it up and light it and then try to cook food. But you can see the amount of emissions that it is actually giving out. Now, what is the problem? We know the problem. It is the environmental and health hazard. Now, many kind of designs have come cook stove. Why they have come up with efficient cook stove is that because they want their food to be cooked in cook stove, because there is a factor of taste in India, which they say if you cook in cook stoves or biomass, it gives a different taste. But for so again, the advantage is pretty much more because they do not require fuel for feeding inside, they do not require money to buy fuel to feed inside the cook stove. They do not have to worry about any construction or maintenance charges. So everything is free of cost, and it is very handy for everyone who resides in rural areas. So they are actually using those kind of stoves. But researchers have thought of it when they thought how to make these stoves, efficient with biomass feeding fuels, and the stove will have less emissions out of it. So they have designed two kinds of stoves. One is known as natural draft, the other one is known as forced draft. The natural draft runs on, gradient of air. Now, like you have seen in the right-hand side of the slide, you can see first one is the forced draft stove. Next one is the natural draft stove. So natural draft stove has some kind of, holes on the bottom. So we know that air moves from, high pressure region to the low pressure region. So when we light biomass inside the cook stove, it becomes a low pressure region, and the ambient becomes a high pressure region, and the air is actually moved from the high pressure region to the low pressure region. That is how the air intake has been increased. And why we are actually increasing the air intake? Because they say if we increase the air intake inside the combustion will actually be efficient. It will burn easily, and it will have less emission. So that is how they are using small holes in the bottom of the cook stove, and then they are letting the air to rush inside the cook stove to increase the air to fuel ratio. For the next cook stove, for the A1, which says it is a forced draft cook stove, to increase the air to fuel ratio, they actually use a small fan that is connected in the bottom of the cook stove, and this air is actually diverted inside the cook stove to increase the air to fuel ratio. So this air to fuel ratio will help to burn the biomass that is fed inside the cook stove easily, and there will be less emissions. That is how it is done. So there are many cook stoves that have been designed with this concept, and they are running in some of the places where people do rely on wood stove till date. So this is how it is. Uh, you know how it is done in rural areas who do not have efficient stove. They use a small pipe. You can see in this picture, or let's say in this picture, right? She is using a small pipe, right? So this is how she is like improving the combustion of this stove. She is blowing air inside the fuel, and she is trying to make the combustion better with low emission. But this is not enough air that she has put into. So this kind of stoves have evolved out of researchers. Now, this is the concept that we have proposed for a forced draft stove. Now, we should understand when we are talking of a natural draft stove that do not have a fan and a forced draft stove that do have a fan. Now, the stove that has a fan is the most efficient one, right? So, because it is actually driving more amount of air inside the cook stove. So, this is how a forced draft cook stove looks like. It is a two-chambered stove. It has small holes on the top and also in the bottom, and there is a small vent where a fan has been connected, and this fan actually drives the air inside these holes so as to increase the air to fuel ratio. Now this fan is being driven by power, right? So any like devices which has to be run should be run by power. So this fan actually runs with the help of power. But when we are in rural areas, some of the places in rural areas do not have power supply, right? So this is a genuine problem that is prevalent in the rural areas of India, right? So you can see this problem where it is prevalent in the rural areas. The woman here who is cooking in the right hand side of the slide do have a do have a LPG cylinder, you can see, but she prefers cooking on the traditional cook stove. It means that though the LPG cylinder connection is there, but still she relies on traditional cook stoves. So this LPG cylinders has its own lacuna because our PM has tried, has given a lot of effort on like Pradhan Mantri Ujjwala Yojana to promote LPG gases in rural areas with subsidized rates. But then the problem is the person who is actually holding this LPG is the woman of the household. And the woman who cooks, if she asks for money like 800 rupees for every month to get a LPG cook stove, LPG gas cylinder, the men might not like it because he is the one who is actually getting food free of cost. So that's the reason why people in the rural areas do not actually spend so much money on LPG, but they prefer on cooking in biomass cook stove because everything is free, right? So the concept is we are utilizing this heat of this burning biomass, and then we are trying to use a thermoelectric generator in this cook stove, and we are trying to generate a sustainable energy so that we can drive the fan. Right? Now we will talk about thermoelectric generator, what it is and how it works. Right? So this is the point where we as an electrical engineers can come forward and contribute to such real life problems. So what is a thermoelectric generator? It is a small device which works on the principle of Seebeck effect, and the difference in temperature of two phases of the thermoelectrics actually help to convert heat energy directly to electrical energy. So the first figure that you see here is a thermoelectric module. I will not go to the details of how the thermoelectric module works. I'll talk a little bit about it in the later part of my presentation. But this is the module, and it has a number of P and N junctions that are connected in series to each other, and the top and bottom portion of this module is actually covered with a ceramic wafer. And This is how it is, and one side of the wafer has to be provided with heat, the other side of the wafer should be relatively cooler. And once the temperature difference between the two faces of the TG is maintained, we actually get power out of it. Right? So this is how it works. This is the schematic of the next diagram 6 is the schematic of the thermoelectric generator cook stove. I'll talk in detail in the later half. And this is the laboratory scale prototype for the thermoelectric generator cook stove. See how efficient it is. It is burning efficiently without emission, and it is also lighting a small lamp. Right. So this is how the final product looks like. Okay, so now we will little bit understand about what is thermoelectric. So we have understood that the fan that we require to like drive the post draft cook stove needs power, but here in this PV cook stove we are not using any power from grid, and we are solely developing our power from the burning biomass, and then this power is then used to drive the fan, right? So this is how it is, and we will understand a bit of thermoelectrics, how it works. As I said, if we apply power on both faces of the thermoelectric generator, then it will develop power from the difference in temperature. But a very primitive one, if we try to understand, this is how it works. If we take two wires of different material, one is wire A, the other one is wire B, and if we make a junction on 2 points and keep one junction in a hot temperature, the other junction in a cooler temperature, we can see the reflection of a galvanometer stating that the power has been developed between the two wires. This is the fundamentals of how the thermoelectric works. This is how the module looks like, right? As I said, this is a small chip which is like 6.27 centimeter on both the sides, square plate, and it is covered with ceramic wafer. If you see the inner side of this thermoelectric, we can see small legs of P and N type junction. They are connected in series with each other, so that when we put this in any heated device, it can sum up with the voltages, and the power delivery is actually exponentially rising up. Right? This is a small P and N junction, is one section of this P and N junction that is put inside the module. So here we can see it is made up of N-type bismuth telluride material. The other one is the P-type bismuth telluride material. So the N-type bismuth telluride material has more number of negatively charged charge carriers. The P-type has more number of positively charged charge carriers. Now, if we apply heat on one side and keep cooler on the other side, the heat from one side actually makes this charge carriers excited, and these charge carriers tend to move to other side of the thermoelectric. So it moves to the cooler side of the thermoelectric. So this flow of these charge carriers actually gives a difference of density of this charge carriers. So this difference of density of this charge carriers will help to help to let a current flow inside this P and N junction. So if you connect a load or anything, it will actually, load maybe like small bulb or something, it will blow up, right? So this is how it works. So, right. So this is the small C-backed couple that we have seen, and this is the final design of this thermoelectric generator stove. So we have seen the stove has small holes in the bottom and also in the topmost side of the inner combustion chamber. It is a doubly chambered cook stove because we want to encapsulate the air that we are getting and direct it inside the cook stove. So we have then a small heat plate that is been connected with small rods that is totally having conduction with the heat that is being generated from this burning biomass. as this small rod scatter heat from this biomass burning. It will also heat up this plate that has been placed here, which is known as a heat plate. And this heat plate is, after this heat plate, we have this thermoelectric generator, which is then sandwiched between this heat plate and the heat sink, right? So this heat plate and the heat sink, in between this, we have this small thermoelectric generator. So the heat side heat plate is giving T8, that is hot side temperature. The other side is connected with a heat sink. If you have any ways possible seen a CPU that is there, that CPU has a small aluminium heat sink that is placed on top of the electron. So that heat sink actually enlarges the surface area of any electronics or any component that is there beneath, and it will actually let the heat to dissipate with the help of this pinch. So that is why, to increase the surface area and let the cooler side of the thermoelectrics remain more cool, we are placing this heat sink. Because why we cannot keep this thermoelectric generator with a greater temperature difference, because it is such thin plate that it is nearly impossible to let the heat from the heat side to drain to the cooler side. So we need to optimize the heat on the cooler side as well to keep it cool, substantially cool, so that we get the difference in temperature in the heat side and the cold side. Right? So after this, heat has been maintained between the two phases of the thermoelectric. We are actually in a position to develop power. Right? We have witnessed that we can develop power with the difference in temperature of these two sides. So once the power is being developed or generated, what we can do, we can use that power to drive a small fan on top of this heat sink. Now this fan has two purposes. This fan cools down the heat sink, which is being heated from the heat of the thermoelectric, and it also is the same air is directed inside the cook stove, because we need sufficient amount of air to drive inside the cook stove so as to make the combustion better and make the emissions less. So this air is directed inside the cook stove. So this fan has a wonderful work of maintaining the temperature difference between the thermoelectric generators and also moving this air inside the combustion chamber so as to improve the efficiency of the combustion. Right? So this is how it is, how it works. But the power that we have from the thermoelectric, is it sufficient to drive the fan? No. The power from the thermoelectric is small, and the voltage to current ratio is somewhat mismatched with what the load we have in the load side. Now, a small fan, when we talk about a small DC fan, it works on 12 volt, right? It works on 12 volt. But the TEG starts to give voltage from 0 onwards. So from 0 onwards, if we get voltage from a thermoelectric, we cannot use it efficiently to run a 12 volt fan. So we need some kind of electronics to boost up the voltage and power and to drive the fan. Right? So here is the electrical topology that we have used in a TEG cook stove, to drive the fan. So first of all, we have this thermoelectrics, right? We have a diode to make sure that the current moves to the forward direction, right? Then we have a small converter that converts power voltage from 1 volt to 12 volt directly, right? So once we have this ability to convert 1 volt to 12 volt, we can ensure the fan will actually run, right? So once that is done, so once we get 1 volt or minimum of 0.5 volts from the TEG, the fan is actually running, right? So this is again directly connected to the fan that we see, which is a 12 volt fan. Now this is how the fan works. But the thermoelectrics, when the power generation is more, when the stove runs efficiently and the temperature difference between the cook stove heat thermoelectrics is quite better. What happens? We get more amount of power beyond the range of the fan that we are using. But how can we utilize this power to drive more, load to make the power to efficiently use the power, extra amount of power that we are generating, right? So for that, what we have done, we have actually used a small USB. There is a small LED which will show that once the power delivery is more, it is we can plug on to the light or battery to charge. So once this small LED glows, it is a red LED because red LED glows on 2.4 volt. So 2.4 volt is the mark where the fan runs efficiently, and after that the power delivery is actually more than what the fan requires. So when this small LED glows, next load can be plugged in to get the power from this thermostatic. So we are actually making a efficient stove with less emission, less or no emission, and also we are getting power to light a small lamp or even charge a battery or even charge your mobile. So that provision we have kept. So summary of this technology is that we have efficiently designed a forced draft cook stove that works in off-grid areas. The cook stove has the power to light homes with LED lighting. It also has the ability to charge phones, right? And it can overcome the drawbacks of those cook stoves which run on solar PV and which is weather dependent, or if stove which runs on biogas, because biogas is again a very costly source of energy, right? So this is one technology that I have talked about. This is the next technology, which is again a off-grid solutions that we have seen, and I will talk a little bit about the practical problem that is prevailing, and then we will talk about the solution that we have come up with. So this is a small state in northeast in Assam, which is known as Shribhumi. Earlier it was known as Karimganj district. Now it is known as Shribhumi. So this is a small city, we can say, and it has number of villages in the place. So what are the livelihood of the people who are there in these villages? They are dependent on cane and bamboo handicrafts. So they make handicrafts out of cane and bamboo, and they are very much skilled in making mats, like pool mats, which are used in their household, which are used in households to use in humid times, so that temperature in the bed can be cooled down. So they make such mats, they put these mats on top of the bed, and they are actually working good for this humid region in northeast region, right? So you can see this woman who is showing these small strips of cane, right? And in the right hand side, you can see these are the cane, cultivation that is done in this Shribhumi region. And this woman is carrying the dried strips of this cane, and these strips are actually used to weave the mat, right? So this is the mat. This is how it looks like, and this is a girl you can see who is weaving this mat, and they have a weird posture of like sitting for long hours, and they have complaints of backache, neck ache, and hand ache. Those kind of issues are there with these women who are associated with this small household business. So you can see the hands of this woman, how it has weared out by weaving this mats day in, day out, and day in and day out. So this is how it is. and there is not reliable amount of power that is there in this area. So we have taken up this problem and we have seen that this has a huge market, not in India but also in places outside India, right? Even because this is a sustainable thing, it is made of biomass and it is sustainable and it is used to make many handicrafts as well, like bags and other things. It is also used to make bags, sofa, and small sitting stools. So many things are made out of it. We'll see a small video how the woman actually does the work. So she is stripping this cane plants, and finally, if you want to see, this is how the woman strips this cane with mouth and hand. They are actually stripping this cane slips. So, and this is the final thing, how they are weaving this cane strips into mats. They get very minimal amount of money and it is very difficult for their sustainability, but this is their primary business that they do in a household. So most of the people, most of the household have women who are engaged in this kind of small household businesses. Also, yes, you can see this small girl who is actually weaving this mat. This is a mat of like 5 foot to 6 foot. This kind of various other dimensions are there, right? So this is how it is. On the right hand side, you can see there are a number of bags and baskets which uses this cane mats to like weave this bags and baskets. The money that they get from selling this party is like 1500 rupees, which is very small amount of money. Most of the money is taken away by the middleman itself. So whatever remains in their hand is very small amount. So this is this on the left hand side you can see we have developed this standalone system which is a solar powered cane slicing machine. So this is a lab based system. We have put it in the lab, and this is a field based system which is a portable one, and we have deployed this machine, solar powered cane slicing machine in the field. And this project has been funded by Department of Science and Technology, and they have funded and we have successfully deployed also, and people of Shribhumi region are using this machine to slice cane in their day-to-day life. So this is one thing. One another technology I want to like show you. So he was a scholar of mine while I was working in NIT Silchar. Maybe you can see him around in your campus as well because he is a faculty now in computer science department. So, Chad, are you there? Pawan, is he there in online? Hello?
Yes, ma'am. Sir was now in the AML department.
Okay. So anyways, so I wanted to like project his work as well. So he shared, he has worked under me, and he have successfully developed a solar powered assisted device for visually impaired people. So this is also a standalone device. Whenever you want to go outside, the whole device charges by itself, and it has a number of features like it will navigate you through the unknown places, and it will prompt those things in your ear to make you understand the environment where a visually impaired person cannot actually walk through. So this is a very noble device that has been developed by Shaq. So yes, we are also hoping for patenting this device. and it is successfully working. All right. So I have come in the final stage of my presentation. So this is our Sustainable Energy Lab at School of Agro and Rural Technology of IIT Guwahati. We have number of instruments like to measure the emissions. We have solar and wind emulators, and we have, this is the research group that I am working with, right? And yes, I want to motivate you people, like we as an electrical engineer have lot of potential that we can put through our knowledge to the rural areas. So when we talk about rural areas, like people are a bit reluctant about talking about technologies because they cannot think out of the box and like take up projects which can benefit the rural areas as well. So we should all come forward, take our own thing, and keep our vision open and wide, and see there are number of problems that are still there in the rural areas, and we can use our expertise of electrical engineering, and we can come up with solutions that are efficient, clean, and affordable for these rural people, and we can try to help mitigate the climate change thing with our own possible bit. So with this, I want to wind up here. Thank you very much for your patient listening. Thank you, Pawan, Dr. Pawan, for the opportunity to present our research in your conference. I'm very lucky to have you all. Thank you. If you have any questions from your end, I will be happy to have it.
Thank you, ma'am. Happy to have you. And first of all, thanks for accepting our invitation over here.
Yes, yes. Thank you, Pawan. Thank you for having me. We have a long lineage from INIT Silchar, and so good to see you after such a long time.
Thank you, ma'am. So we have a number of known faces for you here. We had Ramudu sir, Balakrishna sir, and Basha sir, Bala sir.
Okay.
Hi, madam.
Hello, hello. How are
madam?
you?
Good, madam.
So
I'm good, madam.
I think that's good.
Yes, madam. And one more 2 hours faculty is there, madam.
So good to see you.
Nadeem sir is also over here, ma'am.
Yes, yes. Hello,
Nice to
hello.
hear you after a long time, ma'am.
Yes, yes, yes. We have met after such a long time. None of us are in NIT Silchar. Everyone has moved on.
Yes, ma'am. Mostly who have been at that point of time, most are left NIT Silchar right now, working at different
Yes.
locations. But lucky we had more number gathered over here, especially in our department.
Right. The sad part for me being here, I have none.
Yes, yes, ma'am. So, madam, let us conclude the session with a bit vote of thanks, madam. Right.
Okay.
Thank you so much, ma'am, for your beautiful session. Truly, at this particular growth generation where different aspects are growing, sustainable development is one of the key aspects, and you really mentioned about all those in a very understandable way, and it was really important right now for the growth of any aspect right now. और आपने जब कहा था कि सल्चर हमारे यहाँ पे उसे कटलपोई करके बोलते हैं, और अभी भी हम देखते हैं हमारे दादा दादी लोग पैसे बचाने के लिए सच में लाते हैं और थोड़ा बहुत काम उससे चला लेते हैं. तो truly connects a lot. It was very connecting and very important as well. Thank you so much for your beautiful presentation and research, ma'am. Really means a lot. Thank you, ma'am.
Thank you so much. Thank you for having me. I was very happy and delighted to share my experiences. Thank you so much. I log out, right?
Thank you, ma'am. Let's end up the session over here. So, we will be starting technical session at this point of time.
Thank you. Thank you, Pawan. Thank you, Dr. Pawan.
Thank you,
Okay.
ma'am. Thank you so much.
All the students are requested to leave for your classes. Thank you so much for being here and listening very patiently. Means a lot for all the participants and the people who are invited you. Thank you so much. Coordinators are requested to stay back.